we're going to be looking at the differential equation associated with primitives. That means the differential equation as constant, arbitrarily constant. Before we go into this particular section, I would love you to get your material ready and the open mind. There are, I think, the D part, the D part has a trick that I'm going to be revealing. So I want you to watch this video to the end. Take it step by step, and you're able to get the full concept about differential equation associated with primitives. Thank you. So here there are three constants here. So if there are three constants here, what we need to do is that we are going to differentiate these three times. So therefore, let's take the number one. We have when we differentiate y, we're going to have y prime is equals to when we differentiate ax squared, we're going to have 2ax plus when we differentiate bx, we're going to have b. Then this constant c, since it doesn't have a function x, so it is gone. So we differentiate it the second time. When we differentiate this, we're going to have 2a, and when we differentiate the b constant without the function x, it is gone. And we differentiate the third time, that means y prime prime, or the third derivative, the third order, we have equals to, because this is, there is no function x, so we have 0. So therefore, ladies and gentlemen, this is our answer to this particular question. Now let's look at number two question. And number two question says that y is equals to a exponential 2x plus b exponential x plus c. And look at this also. This question also have three arbitrary constant. So where our arbitrary constant is the a, b, and c. So that means at this point here, I told you in the first question, number one question we solved, the a part, I say that whenever we have three arbitrary constant, that means we're going to differentiate it we're going to differentiate it three times. So when you differentiate it the first time, we have the y prime is equals to this. When you differentiate exponential, then we are going to take 2x, which we're going to have it as 2a exponential 2x plus when you differentiate this one, this is 1. So it's in the center, we're going to have this is out because there's no function here. When you differentiate the second time, we're going to get 2 multiplied by 2, we're going to have 4a exponential 2x plus when you differentiate this, we are going to still get b exponential x. And we differentiate it the third time because of the three arbitrary constant y prime prime prime, we're going to get 8a x 2x plus b exponential x. Now at this very point here, how do we eliminate the arbitrary constant? That is the target. So whenever you are solving a differential equation associated with primitives, then how do you take away those arbitrary constants? How do we eliminate it? Now, if you look at this equation, let's call this equation our equation one, and let's call this one equation two, and let's call this one equation three. So all what we need to do here now is that we can multiply, maybe if you like, you can multiply equation one by 2. So when you multiply equation 1 by 2, you find out that this 2a exponential 2x will become 4a exponential. Then we're going to be able to take those exponential, those out. So let's assume we multiply this particular equation 1 to be multiply it by 2. So when we multiply by 2, we're going to have, therefore, we are going to have 2 exponential 2y prime is equals to this particular 2 times 2, we have 4a exponential 2x plus 2b exponential x. So, and remember our equation 3, our equation 2. So now compare with this equation 2. In an equation 2, we have y prime prime is equals to 4a exponential 2x plus b exponential x. So if you look at this now, we can subtract this equation, let's call this now equation 4. And let's still call this man, this is still our equation 2. So we can subtract our new equation 4 from equation 2. So any which way. So let's assume that we are taking equation 4 minus equation 2. So therefore, when we minus this will go with this. So therefore, we're going to have 2y prime minus y prime prime is equals to 2b exponential x minus b exponential x. Can we see that? So 2b exponential x minus exponential x. And when we do that, we're going to end up having 2y prime minus y prime prime is equals to 2. Two of these will take away 1, so we're going to still have 1 left. Now, let's call this equation 5 so that we can easily pick it out. Now, I already compared 1 and 2. So now let's compare differential equation 2 and also differential equation 3. So when we compare the three of them, these 2 and 3, and that means you are going to multiply this by 2. And when we multiply this differential equation by 2, here we're going to have 2y prime prime is equals to 8a exponential 2x plus 2b exponential x. And we pick our equation 3. And when we pick our equation 3, we are going to have y prime 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 is equals to 8a exponential 2x plus b exponential x. So what we need to do here is that we're going to subtract the equation also, just like the way we subtract it here. So we're going to subtract this, and this man will go. So when you go, we are going to have 2y prime prime minus y prime 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 is equals to, we have 2 of these. We take one of it, we're going to see have b exponential x. Now let's call this equation 6, differential equation 6. And now let's compare our differential equation 5 and the differential equation 6. And when we compare the both, you find out that we're going to get something like, here we have 2, let's start with this, 2y prime minus y prime prime. Then we have minus 2y prime prime. Then we have, because of the minus here, the minus should also affect this. We come plus y prime prime prime. Then we subtract this from this. So when we subtract this, so here will now become 0, which is equals to 0. So we can rewrite this. So we can rewrite this as, here we have 2y prime minus 2y prime minus y prime prime minus 2y prime prime. We are going to end up having minus 3y prime prime. Then we have plus y prime prime prime, which is equals to 0. So in writing all of these can be written as y prime 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 plus minus 3y prime prime, then plus 2y prime is equals to 0. Fully x is equals to this. So all of this is same as this particular differential equation. So we are able to eliminate the arbitrary constant. So now let's go to the question number 3. Now the C part, in this C part, we should also differentiate this with the primitive constant. And at this very moment here, in this number 3, we discover that we only have one arbitrary constant. So therefore, we're going to differentiate it just once. So when we differentiate this, we're going to have y prime is equals to, here we are going to have c plus, 4x. So since we know we have something like this, we are going to make this C the subject of the differential equation. And when we make that, we're going to have C is equals to y prime minus 4x. So since we have gotten C is equal to y prime minus 4x, you can substitute this equation, let's call it equation 2, substitute C into equation 1. So therefore, we're going to have our y is therefore equals to, now what is our C? Our C is all of this. So we're going to have it as x into y prime minus 4x plus 2x squared. So when we have substitute this, then we have now having our y is equals to, or you multiply, you have x, we're going to have x y prime minus 4x squared plus 2x squared. So when we take this, we are going to be having, when you sum this, because they have the same term, we are going to have y is equals to x y prime then minus 2x squared. So we can collect, so that we'll be able to get our differential equation. So our differential equation one side, then we're going to be having something like x y prime minus y is minus 2x squared is equals to 0. Because we maintain our x y prime, we also maintain our minus 2x squared, then we bring back this minus y into this. So at this point, we can actually also take, so the task here was for we to remove the arbitrary constant c, and with this very differential equation, we have discovered that the arbitrary constant is no more there.